Today we're going to start Unit 4, Congruent Triangles, and we are going to go to the second Unit 4, Day 2. In Unit 4, Day 2, we're going to be talking about something called the triangle angle sum theorem and the exterior angles theorem. So the triangle angle sum theorem. The triangle angle sum theorem states that the sum of the measures of the angles of a triangle is 180 degrees. So which angles are those? Any angles inside of a triangle will all add up to 180 degrees. So here we're going to write in our notes that in this case, angle A, B, and C add up to 180 degrees. So here we have it. If we have a right triangle, where the box means 90, and we know this angle is 60, this angle is 30, because all three angles have to add up to 180 degrees. If I have an obtuse triangle, and this angle is 120 degrees, and this angle is 20 degrees, then that's 140, which means this one would have to be 40 in order to add up to 180 degrees. So, all the angles inside of a triangle will add up to 180 degrees. So when we take a look at our first triangle, we see we have interior angles. So we write across the top 24 degrees, 37 degrees, and angle 1. Those three angles will come up to 180 degrees. So we're going to add our like terms, 24 and 37 equals 61, plus the measure of angle 1. We go ahead and change that to an x. Our variable, our unknown, is equal to 180 degrees. Next, we're going to subtract 61 from each side, and we get that x is 119 degrees. In this case, x, which is 119 degrees, is actually the answer that we're looking for. So I write in here 119 degrees. So what we're going to do is we're going to take what we have learned, that the interior angles of a triangle add up to 180, and we're going to problem solve. When I take a look, I'm looking at the triangle over here, the triangle on the left. I'm given two angles, 66 and 84, and I should be able to find angle 1. So, again, we want to look for interior angles in a triangle because they add up to 180. When I take a look here at the triangle to the left, I have 66 and 84, and 66 and 84 will add up to 150. What I want to do now is I want to take 180 and subtract 150, and I get 30 degrees. So angle 1 in here is 30 degrees. Next, when I look at my triangle over here on the right, I only have one angle measure, and that's 43 degrees. I do not know what angle 2 is, and I don't know what angle 3 is. However, what I could do is look for linear pairs. So a linear pair forms a straight line and have one adjacent side. So 84 degrees and angle 3, again, makes a linear pair. Okay, so what we want to do here is, again, we want to take 180 and we're going to subtract 84, and we get 96. So we're going to go ahead and write that in. The angle 3 is 96 degrees. Now, my triangle on the right, we have two angles and we're missing one angle. Well, we definitely know that three angles inside of a triangle will add up to 180. So we're going to call angle 2x, and we're going to say x plus 96 plus 43 equals 180 degrees. We're going to solve for x by adding like terms, and let's see what we get. 41 degrees. So we're going to go ahead and write that in. So we have all our angles. We come over here. Angle 2 is 41 degrees, and angle 3 is 96 degrees. Next, this is a U-try. You'll push pause, and you'll try the problem, and then you'll push continue, and we'll do it together. So here you see the word bisect. So bisect, by, to, sec, sections. So segment BC, which is here, is splitting this angle into two sections. two congruent sections. I can see now that there's a box here, which means 90. And so if we split 90 into two congruent parts, we get 45. So take a look at this. If we take a look at it, we have two angles in our top triangle, and we have two angles in our bottom triangle, and we know that all the angles add up to 180 degrees. So therefore, we're able to answer angle 1 and angle 4. And voila, here we go. Here we're going to be combining an old concept with a new concept. Take a look. We are given information that the lines are parallel. When we're given information that the lines are parallel, we definitely want to look for alternate interior. We want to look for corresponding or same side interior. I will tell you that with alternate interior, we can do something that I like to call the Z test. So with this, if you take a look, alternate interior, those are the angles that are inside these corners. So let me go ahead and bubble this in. It's here and it's here. And those angles are definitely congruent. Here, if the Z is turned the other way, then it's actually here in this corner and here in this corner. So what we're going to do is we're going to mark those off, and we're going to find out if we see any alternate interior angles. When I take a look, and I look at this parallel line right here, and this parallel line right here, and this transversal, I can definitely see my Z. So I want to take a look and see which angles are congruent. I can see that this angle right here, 49, is going to be the same as this angle right here, which is angle 4. So here are my little curves within my Z, the angles, alternate interior, that are congruent. So what does this tell me? It tells me that angle 4 is 49 degrees. I can also see that if angle 1 and angle that's 73 degrees are also alternate interior, therefore I can write that angle 1 is 73 degrees. Now where did I get all of this information from? I got this from the fact that we're dealing with parallel lines and they are cut by transversal. So now that I have this information, I can go ahead and fill in my linear pairs. Go ahead and take a look right here. Angle 4 and angle 5 are linear pairs. So if I subtract 49 from 180, I get 131 degrees. So I'm going to go ahead and write here 131 degrees. So what else are we missing here? We can see here that 73 and angle 3 are a linear pair. So I'm going to take 180, subtract 73, and let's see what we get. So we get that that angle is 107. Take a look. 107 is supplementary with 73, and that adds up to 180, so a straight line. And then on the inside, we see a wonderful triangle, and we're going to add up 73, and we're going to add up 49, and what we're going to do is we're going to subtract that from 180, and what we get is that angle 2 is 58 degrees. So now we have all of our information, and we could definitely put it as our answers. For this particular problem, I would like for you to try it, and then we'll see how many of the answers you get correct. So we start off by writing down each angle, and each angle here, take a look. This is one angle here, 9x plus 3. The other one is 11x minus 21, and the third one is 5x minus 2. What we're going to do is we're going to combine like terms, add our x's and our constants, and see what we can get to simplify this. Once we simplify and combine like terms, we get 25x is equal to 200. And then once we divide each side by 25, we get x is equal to 8. So hopefully that's what you got. And what I'm going to do is I'm going to go ahead and put 8 over here. I need to find out what the measure of angle D is. And so I'm going to plug it in. Here's angle D. Here's angle D. 5x minus 2. So what we're going to do here is we're going to do 5 times 8 minus 2. And that's going to give us 38 degrees. So angle D is 38 degrees. So we're going to plug in x for the rest of them, and let's see what we get. There we have it. So our theorem that we're going to be talking about today is called the exterior angles theorem. The exterior angles theorem. So what do you think we need for something called the exterior angles theorem? You got it. We need at least one exterior angle. So the actual theorem states that if we have an exterior angle, which is what angle 1 is outside the triangle, that angle 1 is equal to the sum of angle 2 plus angle 3. I like to say the measure of the exterior angle is equal to the remote angles. In other words, those are the angles that are not close to the exterior angles. So in this case, here's angle 1, and right next to angle 1 is this angle right here, which we don't have a number for. And the remote angles would be angle 2 and angle 3. So that's our second theorem. So when we get ready to solve these problems, we're going to think, do we work with our exterior theorem or do we work with our interior theorem? So here we go. Let's problem solve. Let's think out loud. Here, what do you see? Oh, I see an exterior angle. So we're going to use the exterior angles theorem. So the exterior angle, the outside one, is equal to the remote angle plus the second remote angle. In this case, we're not given the measure of the exterior angle. So what we're going to do is we're going to call that x. So I'm going to write x. Remote angles are the angles that are far away from the exterior angle. In this case, it will be 76 and 52. So x is equal to 128. That's the angle that we are looking for. So we can go ahead and write here the measure of angle 1 is 128 degrees. So let's take a look at this next one. We're going to think out loud. We're going to process so that we'll have a model. I take a look at this. I see a triangle. I see one exterior angle. So I am going to go with the exterior angle is equal to the remote angles, the sum of the remote angles. So which phrase or variable represents the exterior angle? And it is 18x minus 15. And that's going to be equal to the angles that are far away, which is angle A and angle B. So the expression for angle A and angle B are, you got it, it's equal to 13x minus 11 plus 4x plus 1. We're going to simplify on one side, and we're going to bring our like terms together. So 13x plus 4x gives us 17x, and a negative 11 and a positive 1 gives us negative 10. And that's going to be equal to 18x minus 15. We're going to subtract 17x from each side. And when we subtract 17x from each side, we get x minus 15 is equal to negative 10. We'll add 15 to each side, and x is equal to 5. So now that we know x is 5, we can definitely go back and plug it in for the other variables to determine what the angles are. Take a look at angle CAB. We're going to trace from C to A to B. We want to concentrate on the middle letter, which is A. So we're really talking about angle A. So angle A is represented by 13x minus 11. So what we're going to do is we're going to take 13, we're going to put in 5, and we're going to subtract 11, and we're going to figure out what the measure of angle B is. So that is 54 degrees. You go ahead and plug in the rest of the angles and then hit play once you've done that to check your answers. And there you have it. In your own words, what are the two new theorems we learned today? Let's think about that. Well, the first one is the triangle angle sum theorem. And the triangle angle sum theorem states that three angles in a triangle, 1, 2, 3, well, let's see if we could do better than that. Angle 1, 2, and 3 all add up to 180 degrees. That's the triangle angle sum theorem. The other theorem we talked about was that if you have a triangle and you have one exterior angle, the exterior angle is equal to the sum of the remote angles, which are the angles that are far away. So what we need to do is just determine when we should use which one. So let's take a moment to go to page 10 in our booklets, and we're going to go through a thinking process and write down a few notes and some examples. So we've worked with some triangles that have all interior angles, and we work with some triangles that have interior and exterior angles. So what we want to remember is that if we're working with triangles that have all interior angles, we're going to add up each angle and we're going to set it up, add up all the angles, and we're going to set it up equal to 180. So 3x is equal to 180 and x is equal to 60. So each one of these angles here would definitely be 60 degrees. So now let's take a look at the exterior angles. If we have a triangle and there is an exterior angle, what we want to do is we want to set the exterior angle by itself. It's going to be over here by itself. So, and it's going to be equal to the sum of the remote angles. Okay, so if we get an exterior angle that is 120 degrees, and then our remote angles should add up to that, and they could be, one angle could be 100 and the other one could be 20. Let's see if I could erase that. Give me 1 second. The exterior angle over here could be 120, and these over here could be 100 plus 20. Alrighty, let's see. So what we want to do is we want to take a look at the triangle on the left and see what we notice. We notice that we have an expression for all the interior angles. And so what we do know is that all the angles come up to 180 degrees. So we're going to start off by setting up our problem. So here we go. We have all three of our angles, and we have it set up equal to 180 degrees. Next, we're going to combine like terms. We get 15x is equal to 195. We'll divide both sides by 15, and we get x is equal to 13. We could definitely plug it back in to verify that all the angles add up to 180. Now let's take a look at the triangle over here to the right. It is different from the triangle over here. So let's first talk about what we notice. What we notice is that we have an exterior angle now, and we have remote angles that are interior. So our first thought is to go to our exterior angles theorem. With the exterior angles theorem, we always write down the exterior angle first. And so we write that by itself. So that 17x minus 23 is equal to, oh my goodness, what do I see here? I see a marking. I see the same marking, but I'm only given one expression for the angle. What does that mean? If we have the same markings, it means the angles are congruent. So this angle is 7x plus 2. Therefore, this angle right here is 7x plus 2. So I'm going to write the angles down twice. Once I wrote the angles down twice, I'm going to combine like terms and simplify to solve for x. We'll subtract 14x from both sides, and we get 3x minus 23 is equal to 4. We add 23 to both sides, and we get 3x is equal to 27. We're going to divide by 3 and divide by 3, and x is equal to 9. So what do? We have to think through whether we're working with interior angles or whether we're working with an exterior angle to make sure we apply the correct theorem. This concludes our video for today. Go ahead and try some of the practice problems on your own and ask any questions the next time I see you.